Hi everyone. In the next few slides, I will talk and explain about of the most innovative technologies that the Intel company has made within its brand in recent years. Okay, today in the world, there is a great divide between two classes of processors. There are the typical desktop processors that we have in our builds, Intel or AMD, which are known as x86. And then there are the ARMs, which, okay, there are more types, more design in general, more processors, but the vast majority that we have today are x86 or ARM. And the main difference between ARM and x86 is the is that x86 uses a system called CISC, which means complex instruction set computer. Is a concrete way in which the processor commands are designed to be able to ask the processor to do different operations. We use commands like, for example, load something in memory, do a sum, compare the numbers, and things like that. Thousands of these commands are what make up processors like Windows or Google Chrome. But what is this about CISC? It's basically a system according to which, when give an instruction to the processor, it performs a list of tasks. Each action is mapped to a list of tasks of our processor. The alternative to CISC is RISC, where the commands with which we can communicate with the processor are simpler and only do that what the same processor is made to do. I'm going to give a simple example to understand it. Let's imagine that we have a processor that has the necessary electronic circuitry to add two numbers. Using the CISC design, we could ask the processor to do the sum 8 plus 14 plus 32 plus 24 plus 10. The processor would accept this command and do several sums, one after the other, before giving us the result. We can ask it for a sum of many numbers to our processor. Now, if this design of the processor were RISC, this would not be possible. We would have to order each sum separately. First we would have to say 8 plus 14, and well, we take the result is 22. We ask that it add 32 with 22, and so on with all the numbers basically. Because the processor is not able to add several numbers at the same time. Okay, I start with this explanation basically so that you understand that x86 and ARM are completely different. ARM processors have a very good strategy. That was around a few years ago that makes them ideal for mobile devices and even low power notebooks. And it's something called Big Little. Big Little technology, although it may not sound like anything to you, is extremely popular, and it's what's behind the operation of many of the modern mobile phones. The idea is as follows: can manufacture high performance core and low performance cores. A core designed for high performance inevitably draws a certain current simply because it's on. On the other hand, we can manufacture low power cores, which will consume much less and can be used for basic tasks. but they will not be very powerful. Now, what Bit Little does is combine a group of low power cores with one or more high performance cores. In this system, basically when we launch a task, it will be executed by default in a low power core. And if the task is too intensive and needs more power, then it moves to the high performance core. These type of processors are in fact known as SoC, or System on a Chip. Practically the whole phone is a chip in and all the rest are peripherals. And that is quite far from the classic generic processor such as those of computers. All this part I have mentioned has been because a Samsung laptop is one of the first in the world to carry an Intel processors that uses exactly that philosophy. In fact, Intel has basically created a complete computer within a single chip, which I will explain below. To explain how it works, I will use some images of a Lego made by Intel to basically explain how its processor works, such as what layers it has and how it's formed. And why have they made a good concrete Lego? Because basically this processor is made in layers. It's a new type of architecture that Intel is working on. What they propose with this new processor is to put core on top of core, on top of the other component electronics, on top of RAM, like a sandwich of many larger scale electronic components and communicate vertically. Here, as you can see, we would have the first layer, which is basically all the connection we have with the PC, the input and output elements, including from the NVMe system and USB Type-C connections. This is our next layer. Here, as you can see, is the central part. First, we have the memory controller on top of everything. The typical RAM memory controller, that is our processor. The processor is the one in charge of controlling the RAM. So here we have a Sunny core. This is the great core, the bit core. This core is in the fact from the 10th generation of Intel, of the current processors that exist on the market. I mean, what we would have a normal and current laptop is if it had an internal processor. Since this is a large laptop core and then this other for small cores, the Tremont, with this here they would be like atom cores. They would be small cores with the much less power. They are cores that we will normally find in very low consumption devices with Intel processors. And basically here we have our hybrid processor system. We did this for cores, all the simplest task will be processed. When it's detected that a task is beginning to saturate one of these cores, as it directly moves to the large core that is in charge here. This is basically the cache. It is the memory that all these cores have in common, which allows them to communicate with each other. Here we have the graphics part. We have the generation 11 graphics. This is basically the graphics card. This is the monitor controller, and here we have the imaging. This would be basically like a graphics processor in 2 dimensions. This is all the graphics card. But here we have it separated, integrated to the processor together with a management module of power and control and debug. This processor on top of the cores, moreover, has a layer with 4 pages of RAM, and on top of this, it has another 4 page of RAM, and the heatsink would go on the top. And basically, this is a new generation 3D hybrid processor. Okay, as conclusion, we can highlight enough the energy efficiency that this technology can generate. This is taken for the granted at the Samsung laptop model has an extreme battery life of 13 hours, which make it a specialized thing for the people who must travel a lot. A disadvantage that could be said of this is that since it doesn't have so many high performance core, it can be said that for now this technology would be only used for productivity tasks and even programming. So for forced jobs such as editing video or using an engineering simulator, it would not do so well. And that's it. Thanks.